Right now, as you're hearing these words, your brain might be doing something that no supercomputer on Earth can replicate, something so deeply connected to the fabric of the universe that scientists are only just beginning to understand it. And by the end of this video, the way you think about your own mind will never be the same. Let's start with something most people take completely for granted. You are thinking right now. Somewhere inside that 3-pound organ sitting in your skull, electrical signals are firing, chemicals are flowing, and out of all of that biological machinery emerges something miraculous. A subjective experience. The feeling of being you. Scientists call this the hard problem of consciousness, and it has stumped philosophers and researchers for centuries. How does raw matter become aware of itself? How does a physical brain produce the experience of seeing the color red, feeling heartbreak, or having a sudden flash of inspiration? Classical neuroscience has struggled to answer this, and that is exactly where quantum mechanics enters the picture. Now, before you tune out thinking this is just pseudoscience dressed up in fancy language, stay with me, because some of the most credentialed physicists and neurologists on the planet have taken this seriously enough to dedicate their careers to it. The theory we are exploring today is known as Orchestrated Objective Reduction, or Orch OR, and it was developed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. Two people who approached the mind from completely different directions and arrived at the same extraordinary conclusion. Penrose started from mathematics. He argued that human consciousness cannot be replicated by any classical computer because mathematical insight requires something beyond algorithmic computation. He pointed to the work of Kurt Gödel, whose incompleteness theorems demonstrated that there are mathematical truths that no formal system can prove from within itself. Penrose believed that human mathematicians can somehow perceive these truths directly, which means consciousness must involve non-computable processes. And the only place in physics where non-computable processes naturally arise is in quantum mechanics, specifically in what is called the collapse of the wave function. Hameroff came at this from a completely different angle. As an anesthesiologist, he spent decades fascinated by how anesthetic gases put people to sleep. What he noticed was that these gases don't work by blocking electrical signals in neurons. Instead, they seem to work by interfering with tiny protein structures inside brain cells called microtubules. These microtubules are like the internal skeleton of your neurons, and they are extraordinarily small. Small enough that quantum effects could potentially operate within them. Here is where the two ideas meet, and honestly, this is where things start to get wild. Penrose proposed that quantum superposition, the ability of a quantum system to exist in multiple states simultaneously, could occur inside these microtubules. And rather than collapsing randomly, as quantum decoherence theory traditionally suggests, these superpositions collapse in an orchestrated way shaped by the geometry of space-time itself. The orchestration comes from biology, from the brain's own activity. The objective reduction comes from quantum gravity, a connection to the fundamental fabric of the universe. Hence the name, Orchestrated Objective Reduction. Now you might be thinking, doesn't quantum mechanics fall apart at biological temperatures? Isn't the brain too warm and wet for quantum coherence to survive? This was the primary objection for decades, and it was a strong one. But what nature has been hiding from us is about to change everything you think you know. Scientists studying photosynthesis discovered something that shook the foundations of biology. When plants capture sunlight and convert it to energy, they do it with nearly perfect efficiency. And the reason for that efficiency appears to involve quantum coherence. The energy essentially explores multiple pathways simultaneously, finding the most efficient route in a way that classical physics simply cannot explain. This was discovered in real biological systems at room temperature, operating in the messy, wet environment of a living cell. The idea that quantum effects cannot survive in biology was suddenly looking a lot less solid. Then came the birds. Research into how European robins navigate during migration revealed that they appear to use a quantum mechanism in their eyes. A molecule called cryptochrome seems to generate entangled electron pairs that are sensitive to Earth's magnetic field, allowing the birds to sense magnetic direction with remarkable precision. Again, quantum entanglement operating in a living creature at body temperature, performing a biologically useful function. Nature, it turns out, figured out how to use quantum mechanics billions of years before we even knew quantum mechanics existed. The brain itself has also been yielding surprises. Research on ion channels, the molecular gates that control electrical signals in neurons, has suggested that quantum tunneling may play a role in how they open and close. The sense of smell has been proposed to involve quantum vibration detection rather than simple molecular shape recognition. Everywhere scientists look with fresh eyes, quantum effects keep showing up in places biology was never supposed to allow them. So what does all of this actually mean for your consciousness? Because this is where the theory makes a claim so bold it sounds like science fiction, except it's being published in peer-reviewed journals. The Orch OR theory suggests that each moment of conscious experience corresponds to a quantum computation occurring in the microtubules of your neurons. These computations are not random. They are shaped by quantum geometry, by the curvature of space-time at the Planck scale, which is the smallest meaningful scale in the universe. Your thoughts, your decisions, your sense of self may literally be ripples in the fabric of space-time itself. Penrose and Hameroff have proposed that this connection to space-time geometry is what creates genuine understanding as opposed to mere information processing. A regular computer shuffles symbols according to rules. The quantum processes in your brain, if the theory is correct, are doing something qualitatively different. They are touching the universe at a level so fundamental that the distinction between mind and matter begins to dissolve. Let that sink in for a moment. Your consciousness might not just be a product of your brain. It might be a feature of the universe. Not something the universe created by accident as a side effect of evolution, but something woven into the mathematical structure of reality itself. If this is resonating with you, if this is changing the way you think about your own mind, take a second and subscribe so you don't miss what's coming next on this channel, because we are just getting started. This connects to another idea that has been gaining traction in physics, which is the notion that information is fundamental to the universe. Some physicists, most famously John Archibald Wheeler, have proposed that at the deepest level, reality is made of information, not matter or energy. Wheeler's famous phrase was, "it from bit," meaning that physical existence emerges from informational yes or no questions at the quantum level. If that is true, then consciousness, which is the processing and experiencing of information, may be far more central to the nature of reality than we ever imagined. Now, critics of Orch OR make valid points worth acknowledging, and I think it's important to be honest about this. The timescales for quantum coherence in the brain appear to be far shorter than the timescales of neural activity. Some physicists argue that even if quantum effects occur in microtubules, linking them to consciousness requires leaps that the evidence does not yet support. These are legitimate scientific concerns, and the theory remains controversial. But controversy in science is often a sign that something important is being explored. What is undeniable is that consciousness remains the deepest unsolved mystery in all of science. And the classical materialist view, the idea that consciousness is simply what the brain does when enough neurons fire together, has not produced a satisfying explanation. It describes the machinery, but cannot explain why the machinery produces experience at all. Quantum approaches like Orch OR are attempting to close that gap by connecting subjective experience to objective physical processes at the most fundamental level of reality. Think about what this means for you personally. Every time you have a sudden insight, every time a solution appears to a problem you have been struggling with, every time you feel a deep intuitive knowing, these experiences may involve quantum processes connecting your mind to the underlying geometry of the cosmos, the universe thinking through you. Evolution, on this view, did not just stumble upon consciousness as a useful survival tool. It discovered a way to harness something that was always there, encoded in the mathematics of space-time itself. Nature built quantum computers long before humans thought to try. Photosynthesis, bird navigation, enzyme reactions, and possibly the human mind itself all represent billions of years of biological evolution learning to exploit the deepest rules of physics. We are only at the beginning of understanding what that means. The question of whether your brain is genuinely connected to the universe at a quantum level may be one of the most important questions science ever attempts to answer. It sits at the intersection of who we are and what reality fundamentally is. And as our tools improve and our understanding deepens, we are getting closer to finding out. So the next time a thought arrives that feels bigger than yourself, the next time intuition guides you somewhere reason alone could not reach, consider the possibility that you are not just a biological machine running a program. You might be a window through which the universe experiences itself. And that is not a small thing, that is everything. If you want to go even deeper, check out this video right here, and if you haven't already, subscribe so we can keep exploring these ideas together.